We're going to do another example using cross products. This time, we're going to not only compute a cross product, but we're going to do an additional step. This problem wants us to find a unit vector that's orthogonal to both of those. So to do that, we need to remember a couple of things. One is that a property of cross products is that the cross of any two vectors is always orthogonal to each of the generating vectors. So what that tells me is that U cross V is a vector that's orthogonal to both of these, but it's not a unit vector that's orthogonal. So what we're going to need to do is generate that orthogonal vector with the cross product, and then we're going to need to find a unit vector in the same direction. Okay. Actually, it doesn't have to be in the same direction, it just has to be parallel to it. So we'll talk about that in a second. So let's set up U and V. We have 4, -3, 1, 4, -3, 2, 5, 3, 2, 5. So going down the line, we have -9i plus 2j plus 20k minus a -6, so plus 6k minus 5i minus 12j. So this vector is -14i minus 10j plus 26k. So we might want to say to ourselves, all right, are we sure that we've done this correctly? Well, the way we want to do that is let's check by dotting it with V. So if I say U cross V dot V, I get -28. So -14 times 2. -10 times 5 is -50. And 3 times 26 is positive 78. So that's -78 plus 78, which is 0. Now, if we want to be really, really sure, we'd also dot it with U. But in general, if you dot it with one of them, it's usually a pretty safe bet. Unless this is missing several components, then it's a little dicier. But anyway, so we can feel pretty good that we have a vector that's orthogonal to both. So let's get a unit vector. So if we call W U cross V, then let's get the magnitude of W. That's going to be -14 squared plus -10 squared plus 26 squared. Now this is off the top of my head here, but if I recall correctly, that is 196 plus 100 plus 676, I think is right. Don't ask why I know that. Also, maybe wrong. So then that's 672. So the square root of 972. And I know we can at least take a 4 out of that. So let's see, 2, 4, 3, which is the square root of 2 times 243, which I know that is 81 times 3. So that's 18 square root of 3. That actually came out kind of nice. So the unit vector is each of these divided by that. So we end up with -7 over 9 square root of 3 negative 5 over 9 square root of 3 and 13 over 9 square root of 3. And so that's a unit vector in the same direction. Now, I want to make an important point here, which is that, let me get out of the way of that unit vector in case you can't see. This is not the only answer to this problem. It's a unit vector that's orthogonal. So this vector is both a unit vector and orthogonal to both of those. But so would its negation be. So what we find is that in general, either one of those will work because they're both unit vectors and they're both will have the dot product for u dot product with v equal to 0. And there's your example.